Thank you for joining us today for this meetup, and thank you for giving us the opportunity to share our views on the topic, the trending topic that we have been discussing, or people are moving towards, businesses are moving towards. So I hope I'm audible. You're able to see my screen. If any technical difficulties, do let us know. Just unmute yourself and let me know. So this is going to be, I'll have my session as 35 to 40 minutes. I have a presentation I can talk about, and then I will take your questions. So feel free to post your questions in the chat box, and I will answer them towards the end of the session. I may not take it in the middle because that might interrupt the flow. Possibly some of them I would have been addressing in my presentation itself. So I thought I'll finish whatever points I have to discuss, and then I will take the questions towards the end. And serverless is, this is not to set the context clear. I'm not going to do any hands-on demonstration of how to start the serverless engine and deploy a function. So those are not something that I'm going to do today. So this is going to be a basic presentation based on my experience. I think it was there given in the session as well. So I'm Rajalakshmi, and I'm working in Zoho for the past 21 years. This is my 22nd year at the organization. I've worked in various products, and Zoho being a cloud-based software SaaS company. So we have various products that are needed for the businesses, any business, end-to-end operation of any business. We have products. And currently I take care of the Site 24/7 is a monitoring product, and in that I take care of the application performance monitoring section. So we do have serverless at Zoho itself, we do have serverless functions, and we do make use of some of them, but possibly different stages. So based on my experience of working in the product development and whatever the events that I participate, the people that I interact with, the industry experts of the various technical domain people are in. So what serverless is, how or why it is important, where you will have to adopt in case you have to adopt. It's not necessary that you have to blindly do things because everybody else is doing. So I'll be talking about those few things which are important for this topic at hand. So the agenda goes like this. So the topics that we'll be discussing today are to set the context, I'll be talking about the evolution of the application architecture itself. So how it started 20 years ago when I started, or I don't know about the others, at least when I started software programming, how it was to what it is today, the complete evolution, and then about the traditional IT to the function as a service that is picking up. Then we'll get into that is to set the context of what is function as a service and what is serverless. And then we'll talk about serverless providers, some of the use cases where serverless could be useful. What are the benefits of using serverless, and what are the current trends, and what are the future trends that the industry experts are expecting or looking forward to? What are the challenges, and then about the monitoring needs. And I'll wrap up with my example of a golden circle. So that's going to be, I'll be pretty much spending some 3 minutes on each of these topics. So these are all not something new. These are all some things that you may be already aware of, or you could be expert in this than what I am talking about. But it is always when we listen to some concepts again and again, we get different perspective, we get different ideas. So that's the importance of such meetups and such discussions that we always have. Okay, so let me get into the main topic, the evolution of the application architecture itself, how it started. Possibly the application architecture, if we have to say, it's typically the client server architecture that we are talking about. So what was the client server architecture possibly 20 years ago? So it used to be a simple a server and then a client component, and it used both of which, the server component as well as the client component, resides in one corner of your own office. So it's a physical premise, and the client talks with the server. So that's how the typical client server, it's a simple protocol client server architecture that existed almost some 20 years ago. That's how it started. And then with web picking up, with web 2.0 picking up, Web 2.0 started almost 15, 16 years ago, way back in 2005. All along that time frame, web was only considered as a medium of consuming content, where people started, we were just reading news articles, we were just viewing the videos that were there. But with Web 2.0, web was not just considered a medium of consuming content, it was also considered a medium of contributing content. So people started writing their blogs and uploading. People started taking photographs and uploading, taking videos and uploading. So that is when this cloud itself started picking up, and that is when all the collaboration and communication tools that are required around the cloud architecture started picking up. And then the client server architecture became like your server can be anywhere in the world, and your clients connect using the internet. Again, it could be simple protocols, but then it connect using the internet. The server component can be anywhere else. So with Web 2.0, this transformation was possible. And when we talk about cloud, lot of cloud providers started picking up, and there were many public cloud providers like AWS or Azure or Google Cloud. There are many cloud providers, and people started using whichever cloud they wanted to for deployment, and then the clients connected using the internet as a layer. So that public cloud server started picking. But not everything was moved to the cloud. There were still legacy systems which was held on premise, and people were using even the cloud architecture. So which led to the hybrid architecture. So it was not fully on premise or not fully cloud. It was a hybrid architecture that people are using, and people were using, and still people are, or businesses are moving towards the hybrid cloud architecture. So if I have to put this in a different perspective, a different analogy of how we can present the same thing, what was a monolith architecture, where your business logic to your user interface to the data access layer, the file accessing layer, all of them, even though they are different components, they are all in one system. They were all considered as one system, one mega monolith architecture. That's how the typical architecture was. From monolith architecture, the application building evolved into microservice architecture, where each of these components, be it your business logic or your file accessing layer, your data accessing layer, your caching layer, each of this can be a different microservice container on its own, and your user interface just connects with them. So this is how the architecture has transformed from a monolith, mega single architecture system to microservice containerized architecture. But it didn't stop here. There are still businesses who are now doing this containerized way of deployment. From containerization, things are now moving to serverless architecture. We don't want this server layer at all. I don't want to own the server. All that I need is just a function to do all my work that I want to do. I can just have a function to do a basic IO operation. I can have a series of functions that calls a set of APIs to build a web application itself. I can just have a function or make use of the functions, third-party functions that are already available, and build my system. So that is how the industry is evolving, or industry is moving towards, the application development is moving towards, and that's where the serverless architecture is picking up. So from monolith architecture to microservice to serverless is the transformation that we are seeing in the industry. All of this, why are we doing all of this? At the end of the day, all this boils down to building applications. So application development is important for any business. Any business that we have a problem to solve, and that problem has to be solved by developing applications in software, at least in the software field that I'm talking about. So in that, there are different ways of doing, and the industry or the technology advancements lead to different architectures that are picking up, and businesses have to adopt them so that they are in line with whatever the trend is. So that's the evolution that I wanted to present, so that we have an idea, or we have a background of how these things have come into. Then if we have to talk about, as I said, things are moving to the cloud, and we are writing cloud applications. What are the typical layers in any cloud architecture? So if we talk about a cloud architecture where you write a cloud application, there are different layers, and I have attributed them to 4 important layers. The topmost is your end user layer, which comprises of your web browsers, your mobile phones, your tablets, or whatever you use to connect to the underlying layer. So that is the end user layer that comprises. The next one is your application layer. That's nothing but your software as a service layer, where actually the business logic is hosted. This is what is important that the business owners have to worry about. Rest of the things, they can just make use of the providers that are available. You have to, gone are the days where you have to worry about first procuring all the infrastructure and the other components that are required for you to start a business. 20 years ago, if I have to write a code, I have to first worry about purchasing my infrastructure component. I have to purchase a server. I have to purchase a database component. Today, you can just make use of the providers that are available on the cloud and concentrate or focus only on the business logic. So the business owner's main component is this application layer. Then the next one is the platform layer. So which comprises of the caching servers, NoSQL servers, databases, and the queues, the microservices. All of this comprises the platform layer. Bottommost is your infrastructure layer, which comprises of your physical servers, virtual servers, cloud servers, your load balancer, firewall, complete network components like your routers, switches, all those comprises your infrastructure layer. So why am I talking about all these layers? For any developer or for any the application building business that you own, you have to have a complete visibility of what is happening across all these layers. End-to-end visibility from your end user layer to your infrastructure layer. You have to have the knowledge of what is happening, because the problem could come anywhere. I'm talking about a cloud architecture. In a cloud architecture, if something goes down, the problem could be anywhere. It could be in your application, or it could be in your database component, or it could be in ISP that you're connecting with your end customer with. It could be anywhere. So this is where the DevOps or the IT administrators have to focus on. They should have a complete visibility of what is happening in all these layers. So this is about the various layers in any cloud architecture and the transformation that I wanted to set the note on. Now, let's quickly look at what was the traditional IT layers. This is another representation of the actual layers that are there, from traditional IT on-premise to how the system has evolved to function as a service. Just quick 1 minute on how the whole thing has changed. The traditional on-premise IT environment comprises, or any IT environment comprises of these different layers, starting from your data center to the network, storage, server, virtualization, the OS, middleware, runtime, data, application functions. So in a traditional on-premise, all of this are self-managed by the vendor themselves or by the business owners themselves. It is not provided as a service. So that's how the typical traditional IT is. Then there is this co-locations, where the data center is provided as a service, and you just use that location and you configure your network, you configure your storage, you configure your server. The rest of the stack you take care of and self-manage. So co-location spaces are available. Then the hosting providers, where up to the server layer is provided as a service. Linode is a hosting provider. DigitalOcean is a hosting provider. There are different AWS is a hosting provider. There are different hosting providers, region-specific hosting providers themselves available, where you can just purchase servers from them and then use it. And then comes the infrastructure as a service, where up to the virtualization layer is provided as a service, and then you just configure the OS and deploy your application on top of it. From IaaS as a service, where platform is nothing but up to the data layer in the middleware is provided as a service, and you manage only the applications and functions. In function as a service, you only manage the function. The rest of it is provided as service. In SaaS, everything is provided as service. You don't manage anything at all. You just have to subscribe and start using. Any of your banking, any of your retail products that you use on the mobile app or on the web, or any of your banking applications that you use, or financial applications. Now, all of this are software as a service. So this is for the entire transformation. But with respect to software development or the application development, what used to be as an application development has now moved to function development. And that has led to the birth of this serverless, and that will be the focus of what we want to talk today. So now we'll move on to all about serverless that I had to discuss on the various use cases that we will be talking about. First, let's look at the serverless providers. Who are all the serverless providers? There are different vendors who provide serverless platform which you can use and you can write your functions on top of. So the different serverless providers, this is where I generally miss the what is that, in physical presence meeting. So show of hands, how many of you have used AWS Lambda functions? I'm sure most of us would have used, right? So that's the first thing we experiment with. So there are various providers, but I'm just listing few of them here. Those are the prominent ones which in the industry which people use. So there are AWS Lambda functions which provides these function as a service, and you just have to write your or make use of them, write your piece, and just run it on the Lambda service. There are Azure functions. So the Azure functions are something to be experimented to. See, when we want to experiment the technology, I'm sure as developers, all of us would want to try our hands on the different vendors that are available to see or compare the pros and cons, and then choose whichever is best for us. And that's the right way of doing. So that's another provider that we have. IBM has a function as a service. So there are IBM functions available, Google functions available, Alibaba functions available. And to add on to this list, there are many more Kubernetes, Knative functions and other thing. Just for representation, to add on to this, Zoho Catalyst as a product is available from Zoho, which is again function as a service. You can just make use of it like any other provider. If you want to experiment and see for yourself, you can just use the Zoho Catalyst and see how it helps you solve your serverless needs. Let's put all this together. Let's represent. Let's not get into any vendor specific in this talk. I'm not going to give any. We are not here to give any sales pitch of use this or use that. So let's just call them as function as a service. There are different vendors depending on what your business need is and what you want to try. You can try whichever vendor you want. So let's just call them as function as a service or serverless component, and move on to some use cases where you can really make use of the serverless in your business or in your applications. First thing is using, it's not in any order. There are hundreds of use cases available. So I'm just discussing some 4 or 5 important use cases that I felt is important where serverless could be helpful. Possibly you have a different use case and you can try it there as well. So an entire web application can be built using a serverless function. So it's not that you have to write everything of your own. You just have to include some amount of intelligence in your client layer and then make use of all the available functions. So you can make use of the authentication service functions that are available, the OneAuth or the that authentication service is available from various providers as well. You can just make use of them. For data storage, if you want to use it in AWS, you can just use the AWS data storage as functions and make use of it in your application. And you can have all the APIs and make use of what authorizations you need to give. You can write some small custom microservice which will take care of some event-driven notifications if you want to give. So all those available functions can be made use of. You just have to understand and find out what are all the different services that are available, and using them, you can build a web application yourself. Because if your focus, if there are vendors that are already available and that are, if there are payment gateways that are already available, why do you want to build a payment gateway yourself? You just make use of them. Make use of it, try to integrate it into your application and focus on your main idea. Focus on your business logic. That is what is important. That's when you will be able to take your business to the market ahead of your competition. So serverless web application, the web application itself can be built using serverless, depending on your use case, depending on the components available, you can just build it. Then if you have some cron jobs to be scheduled, there are scheduled jobs that you need to do. Not that all your jobs that you do in your application are user driven. User driven means you just go click something in a browser, then the request transfers to the server, collects all the information, does all the processing, gets back the data and renders. That's a user driven task. But in any application or any software that we have, there are a lot of jobs that could be run in the background. There are background jobs for data processing, for data archiving, data backup and restore, or some data cleanup that you want to do. All that can be done without user intervention, and such schedules alone can be made or converted into a serverless function. So that's possible. So you just have to read, you just have to pick, when a scheduler is done, the function reads the scheduler, does all the data processing, and you can also do notifications. The notifications can be, or you can write some code or make use of existing functions to do notifications. The notification could be sending an SMS notification, could be an alert notification, or it could be a send an email notification, could be even a voice call notification, could be anything. So there are functions available for that. So most of the background jobs that can be done without any manual interventions can be converted into a serverless, using a serverless function. So see if your application have such use cases and see if you can convert them so that it can be done easily. So that's again another use case. Multi-language support is something important in a serverless architecture, because see, usually when we want to write an application, it will be mostly like you choose the language where you want to write the application. So you either decide you want to write it in Java, or you want to write it in .NET, or you want to write it in Node or Go or Python. That's not the case with serverless. Serverless brings the ease of you can support any language in the different functions that you have, because you're only having a code that is going to run the small function that you're having. So that brings in the beauty of making use of the experts available in each of the language. Java is known for scheduling. You can make use of the scheduler jobs that are available from Java. And if you want to do some Windows level process restart, and for which you make use of .NET applications, you can make use of it there. So depending, and you want to write some native code, and in a mobile application, there can be a JavaScript language that can be used, which can be done both in web browser as well as in a mobile application. React Native can be used for that. So so depending on what the function you want to do, the different languages can be made use of, and you build a strong application for application ahead of your competition. So at the end of the day, all applications are built for some business purposes, and all businesses have end users. So satisfying your end users is important, or addressing their problems, giving a better user experience ahead of the competition. So these are all the primary factors for any business. And we are only going to see how we can make use of the existing technology or the advancements in technology to do that in a better way. So that's what we have to be focusing on, in which case for serverless, multi-language support is a use case that is possible. Cicd integration. So I'm sure all application development takes care of any of the, there are still applications which does the old waterfall model of development, and there are agile applications, but most of them have moved to, cloud applications have moved to this agile way of this having this continuous integration, continuous delivery possible. Here, what you can do is, when you finish writing a code, whatever that can be automated, you used to write a script and do all those things. Now with serverless, there are functions that are available which you can make use of, so that you can do it in a quicker way. So when you write a code and check in, there could be a function that takes the code, builds it, deploys it, and test it, deploy and release it. So there are functions already available. So you don't have to waste your time to write scripts for them. Make use of the existing functions in all the stages of your CI/CD pipeline, so that your releases become even more quicker. So that is another use case where you can use serverless. And there is a lot of things that can be done in image and video manipulation with respect to serverless. That could, because now if you see, the whole world is now moved towards the remote way of working. And the remote way of working has brought in the remote communication and collaboration tools, which require more of, say, this very own webinar, that the meetup now we are having in a remote platform. The video streaming is important. Audio streaming is important. There are a lot of image and video processing that are required. And that if we take this itself as an example, some of you could have connected from your mobile. Some of you could, I am connected from my desktop. So some of you could have connected from your tablet. So depending on the device you are connected from, the image or it has to be rendered in an appropriate way. And the Zoom, we are connected through Zoom. That's again a product development product. Could be any software that is required, or that is a video manipulation software. They can make use of the existing functions that are available that can help with having this, streaming this in a in a way that is required based on the device that is being used. So that is again another use case that is possible using serverless. And with respect to image manipulation, you may want to shrink the image and put it as a thumbnail in some of your websites. So that's again possible using functions. So it could be, the input could be an image or a video, and you can, the beauty is you can make use of any of the third-party tools that are available. You can make use of Google's Cloud Vision API, you can make use of AWS recognition, or there are other vendors that are available. All that we need to know is what are the vendors available, what are the different functions that are provided, which I can use it in my application so that I make it better and give it to the customer. So that's another use case where serverless is really helpful. So these are some of the use cases. Actually, we can talk about, I've just chosen 5 different use cases from that can help in 5 different areas, like the web application building or the image processing or the cron job scheduling that are required. There are different use cases. Depending on what your business needs it, you have to select the use case and you can apply the serverless in that. Let's move on to the next section, which is serverless benefits. So what are the benefits that we get by using serverless? Let's see what are the benefits. There are, see, anything has both pros and cons. I'll be talking about the benefits. I will also be talking about the challenges. So depending on what your business is, you'll have to select. So the primary benefit that I should say, it's not in any order. So it's just I've just chosen 5 points for each of the subtopics because otherwise it would be too much. So first important benefit could be it reduces complexity. So I don't want to be managing this complex wires and networks and architecture for myself. I leave that to the vendors. All that I am worried is only writing function. I don't even have to worry about my application, or I purchase the server. Do I do the configuration of the server correctly? No, I don't want to worry about all those things. I want to keep it simple. So simplicity is what is important, needed, and I want to do that. That reduces the complexity. So serverless brings in that, and that's the important benefit of serverless. Serverless reduces capital expenditure on your business. I have seen this happen in my own case, and I've seen this or heard this from our customers too. What I'm trying to say here is, if you, all of us, when we want to experiment something with respect to cloud itself, I want to try a new module, or serverless, or it could be I want to purchase a server and try out a module, or whatever we want to do. We go today, resources are available. We purchase the resources. It could be either any of the cloud providers, AWS, Azure, GCP, or any cloud provider. But what we generally do is, when we go subscribe for an account, we use our credit card or the company's credit card purchase to do the subscription. With that, the payment is not my department. That's another department. There is another finance department that takes care of the payment. So every month, they don't know what are the resources that we are using. So most of the time, and there is a study that says that 30% of the resources are not used properly. So we pay more for not underutilized resources. So that's a great, that's a great loss for the organization or for the business. Whereas when you use the serverless, you're not going to own the server. You're not going to own the infrastructure that you're having. So that reduces the capital expenditure. There have been a lot of studies that has proved that 30% of cost reduction or 30% of your resources are underutilized. We don't use it fully. In such a cases, it's going to cost you more, and going serverless definitely reduces your expenditure. Just keep in mind, I will talk about the same point in challenge as well. I'll give you the difference between what is a challenge and what is a benefit. So for now, serverless definitely helps in reducing capital expenditure. And it reduces the time taken for any release cycle. So we saw we could do a lot of automation in the entire CI/CD pipeline. What used to take 60 days is the typical lifetime that takes for releasing any product, meaning after your ideation phase, you're sure what you want to release, then you can develop, and then you do some POC, and then you do some testing, deployment, release. If it takes 60 days, using serverless functions, and there are other functions that are available which you integrate and use, this can be drastically reduced, and you can do the same thing in 1/4 of the time. So that's the general study that has been taken. So it reduces the time taken for any release cycle. And it definitely helps in easy completion of scheduled tasks. We saw it in one of the use cases itself. Cron jobs and scheduled jobs are easily done or quickly done using serverless. Serverless also reduces the impact on the environment. And this is important one that all of us have to be focusing on. We need not, it's not that somebody else is deploying the servers, I'm just using them, why should I be worried about it? No. As I said earlier, 30% of the resources are generally underutilized. There is so much of energy wastage that is happening, be it in the form of the electricity, or in the form of the AC that is required for cooling the system, the toxic gases that it releases to the environment. Definitely that is there, and reducing it by 30% definitely reduces the impact of the environment. Go green computing is possible using serverless. So these are some of the benefits of serverless. Let's move on to the trends. What are the trends? What are the current trends and what are the future trends that people are seeing or people are expecting? It is more like it is going to be serverless. Whatever we say is still in its nascent stages. See, cloud itself has been there in the industry. We are talking about cloud technologies for the past 16 years now. There are still businesses which have not moved to the cloud. That being the case, serverless is in its very nascent stages, but down the line, we will see serverless, the adoption of serverless more and more. So more businesses and more modules will start becoming making use of the serverless. Serverless everywhere is one of the trend that is upcoming. And a connected ecosystem by an event-driven approach. See, serverless is required, or it's mostly an event-driven model where it could connect. It is not fixed with any one particular vendor, or it is not fixed with any one particular language. We saw that as well. So that being the case, serverless helps with connecting your private cloud with your public cloud, the multiple cloud providers, to do all the required whatever we need to do as an application. And that helps in improving the ecosystem as such. You become part of the ecosystem. You make use of all the available resources that are available because it is event-driven approach. And lot of open source is picking up. If you are in the APM space, open telemetry is something that is picking up because people don't want to lock themselves with one particular vendor. They want to be vendor neutral, so that I don't want myself to be locked with one vendor. So I want my systems or the tools that I'm using to be vendor neutral. I can choose anyone based on what my need is. And this serverless definitely helps in building such an ecosystem. Stateful applications will also be using stateless. It's not that you have to completely move your application to a serverless application. See, I often say this, for your business need, don't simply go and convert everything to serverless because everybody else is doing, because that's the trend that is picking up. Please don't do that. Possibly your resources or your application doesn't require it to be completely moved to serverless. So see what is the need and then choose what you want to do. What you can do is, instead of completely rewriting your entire application, you can see what component can be rebuilt. There could be some portion which can be rebuilt and which you can make use of the serverless component that you have. So such things will become possible. The stateful applications, they will also see some portion of them being replaced by serverless, stateless. So that is what is the futuristic prediction that is being seen. And function as a service market is expected to grow to 24 billion by 2026, in another 5 years. Today, the market size is around 7 billion. So there are a lot of researchers, and I've given the source link as well. So the important thing that I'm trying to say is, in the next 5 years, there is huge potential. So if you are a application developer that you are using, or if you are a business owner and you want to grab this market share, think that is going to be a potential usage. See how you can grab this market share and grow your business. So that is the trend that is picking up. And when we talk about advancements in technology and performance, I'll be talking about performance in the next slides as well. That's very important. people are looking at improving the efficiency, not just at the software side. Serverless is more of, we are doing it only at the programming level. We are doing it only at the function level. No, people are talking about improving efficiency both at the hardware level. So there are a lot of graphic processing units and the field programmable gate arrays are coming into picture that can help in improve the efficiency. Performance is an important factor to consider, be it serverless with or without serverless. Performance is the need of the hour. I'll be talking about it in the next challenge. So this is something that if you are a business owner and you have your own hardware, there are different architectures that we saw, right? And if you are a person who takes care of your hardware component as well, see if you can use GPUs and FPGAs and improve the performance at the hardware level itself. That's what major industries or major leaders are also focusing on, how we can improve the efficiency from the bottommost hardware level itself. And that's a trend that is picking up. So these are some of the trends in this, in combination with serverless, will be a killer combo to give better performance and be ahead of the competition in the market. So let's move on to challenges. Everything comes with its own benefits. We saw about the providers, use cases, the benefits, and the future trends. The next we'll be seeing about what are the challenges in serverless. So if you have to talk about serverless challenges, performance is an important challenge. So if these challenges are more from, I should say, from a serverless developer perspective. It's not from I'm talking about the challenges more from developer perspective. How come performance is a challenge? I'm not talking about the availability, because I'm not worried about availability or uptime. That is left to the vendor now. All that I have, I'm not deploying the server. I only have the functions. I only write the functions. So with respect to functions, what is my performance? How many times my function has been invoked correctly? How many times the function has hit the hit a threshold? What is the response time of a function? So all those things are very important, because at the end of the day, what we are doing with functions, we are trying to give a application. So response time is important. Today, there are industry surveys which says that 2 seconds is the average time that people expect for any request to respond. Just 2 seconds. If you're writing functions and that is going to take more time, you have to find out where it is taking more time and then improve on it. Because in this fast moving internet world, nobody has the time or patience to sit through pages that are going to take forever to load, right? We don't do that. In any search engine, how many of us go to the second page of any search we do? We just settle with the first page. All these comprehend to say that performance is important. Even if you write a serverless function, you have to write it in an efficient way that you are able to give better results in quick time. So that is very, very important. So remember, performance is a challenge. Security is another challenge. As you are making use of multiple third-party functions, it is very difficult for you to define what level of authorization or what level of permissions you give for one function versus the other functions that you are using, because each of it is a different third party that you are using. You may not be able to apply the same level of policies on all the third party functions that you are using. So you end up giving a function more privilege than what it requires. So that is a challenge that people are facing. When we write serverless also, we have such problems. And making sure that when you are building an application using serverless, and making sure that one user's data is not visible to another user's data is a challenge. So and applying policies across all the functions is a challenge. So security is another challenge with respect to serverless that you have to keep in mind, because these are all in the cloud. It's very important you make sure that the data is safe and secure. That's important. And this is another challenge that people who have started developing and serverless started saying: loss of control. I don't have control of the system. So it used to be that if something goes wrong, I don't know where to go and see, because I only have my function and possibly my function is working fine. Where is the problem? How do I go? Everything else remains a black box to me now. So how do I find out where the problem is? I feel like I don't have control over the entire system is something people feel when they move from a traditional structure or even from an application building. When you deploy the application in your mission, you know for sure that you have you are in control of all the different components. But when you start making use of various other serverless components, then you have a feeling that you are not in control of it, and the sense of loss of control is some challenge that people have said about. Cost. I said cost saving as a benefit. How come then cost becomes a challenge? The challenge here is, as I said in the beginning, you have to see if you really need to move to serverless and then move to the serverless architecture. Not just everybody else is doing, I'm also doing. So that could hurt you or hurt your pocket if you're not doing it in a correct way. Possibly you have a system that requires a server to be running 24/7 doing resource intensive work. Such system is easy if you own the server yourself. Don't try to convert that into a serverless function. You will end up paying more for the serverless function when you do such a thing. If you have a resource intensive, memory intensive work that is being done 24/7, it is better to do that in a system of your own. You purchase the server, or you purchase the server, deploy it and do it there. That could be cost effective than converting that model to a serverless function, because in a serverless you pay for a lot of data transfer. You take the split up of the bill, you will know for what all you pay for. So weigh the pros and cons. If you have done a wrong if you have done a wrong way of using the serverless, when you scale, it could cost you more. So just weigh the pros and cons and then convert it into serverless. This is another challenge, difficulty in testing. As I said, it is linked with that loss of control as well. We don't know what is the entire system. I cannot, because only whatever simulation we do, we face problems only in the real time. The real environment is different from the test environment, the simulation environment that we have. In such a case, I can only test my function that I have written. It looks fine. It works fine. We don't know if it is the problem in a third party that I have integrated with, and it could be different in a simulation environment to in an actual deployment environment. So people have complained of the difficulty in complete testing, and that is again another challenge. So these are some of the challenges in serverless architecture. So when we talk about challenges, some challenges at least could be overcome using monitoring. Possibly the performance challenges could be overcome using monitoring. So how you can address them using monitoring is what I'll be covering here. So you can use any tool for that matter. This is not any vendor specific tool that I'm talking about. It's just some screenshots, but I'll tell you what are the things that you need to monitor. Monitoring tools are important. People might say, I'm just writing functions. Why should I monitor? You see the different things. If you don't monitor it in the beginning and make sure that you are having better performance, you are going to end up in problem at a later point, and correcting it would be very tough. So you may need to know about how many times your functions are called, how many times the function has hit the throttle. Is there any error that it throws? What is the response time it has given? And you also need to know the performance data over a period of time. How is my function responding? How is the response time varying over for the past 1 week? How is the response time? So those things are important. And you may have to know, if you have multiple functions, what are the top 100 slow functions? And for each of the function, what is the response time? How many times it is called? What is the user who is calling it? And each function will comprise of different components. There could be a database component, caching component, there is a file, there is a cron job, and what is the split up of each of these functions? And the complete trace, what time each of these components take. Where do I have to spend to see that this time is reduced? If a function is taking 100 milliseconds, it's fine. If a function is taking 1000 milliseconds, you have to reduce it. You have to know where it is spending more time so that you can reduce it. And definitely monitoring tools help. Every provider has its own, or every provider comes with its own metrics. In addition to that, there are other vendors who can give you these monitoring metrics. Choose the vendor based on whatever is your requirement. Choose the right monitoring tool based on your needs and make use of it so that you can improve the performance of your application, serverless applications that you are writing. And in addition, when you're choosing a monitoring tool, in addition to looking for all those metrics, I generally recommend people to look for ICE when you're choosing a monitoring tool. I stands for I for integration, C for customization, E for extensions. Let me tell you quickly what that means. Integration, integrability of the tool. All said and done, all of us have to depend on monitoring. As developers, depend on monitoring tools. As business owners, depend on monitoring tools. The tools that you decide to use must have integration with the existing tools that you already have. You're not going to replace any tool that you're having. So see to that the tool that you're selecting has integration options, import export options. See if they can work together, and they can seamlessly work together and give you the results that you are looking for. So look for integrability, and there has to be customizability options. We are not going to use the tool any tool as it is. There has to be option for customizing the label or the logo or a field, the text. Some changes we need to do. We are not going to use as it is. See if the tool has such thing. And if you are a developer who's writing the serverless function, see if you are able to give these customizable options in your application. That's when other people will be able to take your application or your function and will be able to use it. Extensibility. All of us are citizen coders. We are living in this era of citizen coders where we don't want to use as it is. We just want to make some small tweaks to it. Drag and drop, and I will form my own dashboard. I don't want to use the dashboard that you're giving. Give me APIs. API support is important. If you're even in your serverless, make sure that you provide API support, and see to that the tool that you are using also has API support, so you can build them together and still it should work. So that's what is extensibility. So when you are choosing a tool, see to that you have all these components. That's when you will be able to seamlessly work together and bring out better results. So with that, I've almost come to the end of the presentation. So I don't think I've exceeded my time. Sorry, I didn't look at the time. So just 2-3 minutes, I'll be done. And then I'll take questions. So this is something that is my favorite. So Start with a Why by Simon Sinek. I'm sure some of you would have read this book. So any change that you want to bring in, any new product that you want to build, or any new feature that you want to do, whatever you want to do, be it at work or at even it applies even for your personal life, start with a why. So why forms the center around which you see how you do and then what you do. That's a golden circle. So if you have not read this book, it's a nice book to read and read about the golden circle. So start with the why. That's a purpose. So you ask 5 why. They say 5 why technique. Do I really have to adopt serverless is the first question that you have to ask. Is it applicable for my business? Is my customer, will they be benefited with such a change? Keep asking why. You will be able to find the very purpose of what you want to do. And then comes the process, how to do, what are the metrics to monitor? Is there a monitoring tool that I have to use? All that forms the process of how to do things, using which the end result. If you do that rightly, if you have your why, the purpose set rightly, the results are skyrocketing and there is no stoppage for you to reach your goals. So with that, when I started, I said there are many monitoring tools in the market. Site 24/7 is one such monitoring tool. It's an all-in-one AI-powered monitoring tool that lets you take care of all your monitoring needs from the different layers that I talked about, from the end-user layer to the infrastructure layer. All that you need to monitor, including your serverless monitoring. The product has capabilities, and I'm not getting into the details. You can figure it out yourself. And it's not a new product. This is part of Zoho. Zoho has been there in the industry for 25 years. Site 24/7 as a product has been there for close to 16 years now. It's a mature product, and we are deployed on Zoho's data center. We have 10 different data centers in 5 different locations. You can choose the data center of your own so that the data resides within your geographical region wherever you want to use. And being a cloud provider, we take security and compliance very seriously, and we get all the certifications required and stringent audit that is required so that customers' data is safe and secure. Privacy is our important concern. So the key takeaways from this session are, we talked about the different transition from monolith to microservice to serverless, where the industry is moving towards, and then all about serverless, the different providers, use cases, the benefits, trends, what are the challenges and the monitoring needs. Depending on your need, you can choose what you want to do. Site 24/7 is an all-in-one monitoring tool. So before I wind up, you just take a screenshot of this, and we'll also post this URL in the chat window. if you subscribe using this link, you get 6 months free subscription. You can try the product yourself. So that's why I didn't get into the details of the product. We are free to do any one-on-one demo of the product. Please contact us. And I'll just like to finish off with this one quote. This is my favorite quote as well. So this is called the Red Queen's quote. This is there in the book Alice in Wonderland. If you have read the book, you would have come across this quote. And the quote goes like this: you have to be running as fast as you can in order to stay in the same place. And if you have to make any progress, you have to run twice as fast as you can. So this is generally applicable for us in life and in the technology world that we are living in. At Zoho, at Site 24/7, we do make sure that we take care of, we look at all the technology innovations that are happening, and we spend a lot of time in R&D and make sure that we take all the latest technologies inbuilt into our product and give it to our customers. Even as a personal friend, it is important for us to keep ourselves updated so that we don't feel outdated. Thank you for your time. I hope I have not exceeded my time. So thank you so much for staying along this long, and I'm open for questions.